Dawn broke over the English countryside on October 3, 1940. A pale, reluctant light spilling across fields still scarred by bomb craters. Smoke drifted above shattered farmhouses, and somewhere in the mist, the rhythmic clang of hammers echoed from a makeshift factory. Within those corrugated walls, a quiet revolution was being born. Rows of exhausted engineers, soldiers, and volunteers labored beside glowing steel presses, assembling curved sheets of metal into half-cylindrical shells. To the untrained eye, they looked like nothing more than tin sheds. But these instant huts, as they came to be known, would change the shape of Allied logistics forever. British War Office Report, 1941. Each segment curved perfectly into the next, bolted together in minutes by soldiers trained in an afternoon. The design was simple, elegant, and unstoppable. The Nissen hut, conceived during the First World War by Canadian-born engineer Major Peter Norman Nissen, had been rediscovered and reborn for a new global conflict. But what emerged in 1940 was more than an echo of an old idea. It was an industrial symphony tuned for survival under siege. Royal Engineers Historical Archive, 1940. The Luftwaffe's Blitz had torn through London, Coventry, and Portsmouth. British command needed a miracle, a way to house men, materiel, and medical units faster than German bombs could destroy them. Reinforced barracks took too long. Concrete bunkers required too much labor and precious cement. But the Nissen revival, led by engineers of the Royal Engineers Design Directorate, promised a new kind of resilience. Portable, repeatable, endlessly adaptable. Each hut could be collapsed, transported on a lorry, and rebuilt in less than an hour. A squad of 6 could raise a full barracks before nightfall. Royal Engineers Field Manual, 1940. As winter set in, the huts spread like steel mushrooms across Britain's bases. Aldershot, Salisbury Plain, and secret airfields in East Anglia. Soldiers called them tin sausages, but when the snow fell and German bombers swept low overhead, those curved shells held firm. Inside, warmth from coal stoves pooled beneath the arched ceilings. Outside, only the faint glow of blackout slits betrayed human presence. The curved geometry wasn't just aesthetic. It deflected blast waves, absorbing shock that would have shattered flat walls. Nissen's century-old insight had saved lives again. War Office Engineering Bulletin, 1941. But the story of the instant hut wasn't confined to Britain's battered shores. Across the Atlantic, another nation watched closely. The United States, not yet at war but already preparing for it, saw the British innovation as a model worth imitating. In Washington's corridors of power, procurement officers debated the cost and speed advantages of this prefabricated miracle. American engineers began drafting their own version. Larger, broader, and more modular. They called it the Quonset hut, named after the Rhode Island naval base where it was first built. U.S. Navy Construction Bureau Log, 1941. By the time Pearl Harbor was attacked in December 1941, the U.S. had produced over 8,000 Quonset huts. They spread across the Pacific like seeds of steel. Guadalcanal, Tarawa, Saipan, yet beneath the industrial roar lay a quiet irony. The British instant hut had already outsmarted its American successor long before the first Quonset reached the field. U.S. Navy Seabees Archive, 1942. The secret lay not in steel or bolts, but in philosophy. The British approach was one of field adaptability. Nissen's huts could be erected by anyone, infantry, engineers, even local villagers with minimal tools. Each curved panel was interchangeable, requiring no blueprint on site. But the American design, while larger and more spacious, required pre-cut foundations and specialized parts that often delayed deployment. In the Pacific jungles, Quonset huts sometimes arrived without the correct fasteners, leaving men sleeping under tarps while supplies caught up. U.S. Army Quartermaster Survey, 1943. Back in Britain, however, the instant hut became an emblem of defiance. In 1941 alone, over 100,000 units rolled off production lines from Teesside to Birmingham, crafted by factory women and retired metalworkers working double shifts. Each unit bore the mark of its foundry, names like Stewart's and Lloyd's, Dorman Long, and LMS Works. The Nissen's curvature was more than design. It was morale rendered in steel. Soldiers joked that as long as the huts kept standing, so would Britain. Ministry of Supply Output Report, 1941. The design's genius wasn't limited to speed. Its half-cylinder shape used 34% less steel than comparable flat-walled barracks while providing equal internal volume. The light-gauge corrugated panels, galvanized to resist rust, could be cut from damaged ship plating, recycling wreckage into shelter. In the resource-strapped economy of 1941 Britain, this was wartime alchemy. British Steel Industry Statistical Bulletin, 1942, on a fog-laden night in March 1941, near a forward radar installation on the Isle of Wight, a cluster of Nissen huts endured their first true test. The Luftwaffe's Kampfgeschwader 55 dropped a string of 500-kilo bombs directly onto the site. When dawn broke, radar equipment lay twisted and smoking, but the huts still stood. Crews emerged, shaken but alive. The huts flexed, one survivor recalled. It was as if they breathed the blast. British Radar Corps After-Action Report, March 1941. Word spread quickly. Soon, the huts weren't just housing men. They became workshops, hospitals, command posts, even churches. Chaplains painted crosses on curved walls. Doctors hung surgical lamps from the ceiling arches. Each unit became a microcosm of the British war effort. Adaptable, stubborn, quietly ingenious. Imperial War Museum Oral History, 1942. But with success came imitation and competition. When American engineers at Camp Endicott, Rhode Island, first studied captured Nissen blueprints, they saw opportunities to scale production for the U.S. Navy's vast logistical network. Their version replaced bolted joints with prefabricated arch ribs and integrated flooring, optimized for tropical climates. Yet the British observed the change with reserved amusement. The Yanks have made it heavier, one engineer quipped, and slower. Royal Engineers Memo, 1942. By 1942, the battlefield of ideas was as fierce as any fought with guns. Which system was superior? The Quonsets' mass production or the Nissen's elegant simplicity? The answer would not come from factories or blueprints, but from the mud, sweat, and fire of the front lines. For every bombed city rebuilt under a Nissen curve, a new front emerged where shelter meant survival. From North Africa's desert winds to the frozen mud of Murmansk, the hut's silhouette became a universal symbol of endurance. And as Allied cooperation deepened, so did the rivalry. Each nation racing not only to build faster, but to innovate smarter. Allied Engineering Coordination Council Report, 1943. By late 1942, intelligence officers on both sides were tracking not just weapons, but architecture. German field reports noted enemy metallic shelters, quickly assembled and unusually resistant to shock. The Wehrmacht's engineers even attempted their own copy, the Behelfsunterkunft Type B, but its rigidity made it prone to collapse under artillery impact. Captured German Engineering File, 1943. The instant hut had transcended its humble origins. It wasn't just a building, it was a weapon of endurance, a structure that conquered time itself, and yet, the deeper secret behind Britain's unshakable design, the innovation that made it both indestructible and infinitely replicable, remained hidden from prying eyes. That revelation would come only later, in the heat of a decisive campaign, where engineering genius and battlefield necessity would collide in spectacular fashion. Rain lashed against the tarmac of RAF Lynham, early February 1943, as transport crews loaded the curved steel panels of Britain's latest generation of instant huts. The men worked in silence, boots slipping on the slick concrete, rivets clinking like the ticks of a clock counting down to invasion. Somewhere across the channel, German field engineers were erecting rigid wooden barracks, structures that took days to build and seconds to burn. Britain's huts, by contrast, could rise from the mud in an hour and shrug off artillery that splintered stone. The secret wasn't luck, nor simply design. It was a fusion of mathematics, metallurgy, and wartime improvisation that turned necessity into mastery. Royal Engineers Production Log, Feb. 1943. At the heart of the innovation was a material breakthrough. The Royal Engineers had begun using high-tensile mild steel, treated through a process pioneered at Stewart's and Lloyd's by metallurgist Arthur R. Payne. Each corrugated panel was pressed to a 10-foot arc radius and reinforced with cold-rolled ribs. The process increased yield strength by nearly 20% while reducing material thickness to 22 gauge. Light enough for 2 men to carry, but strong enough to survive near-miss detonations. The result was an engineering marvel. Shelter that weighed just 3.5 tons yet could withstand a 250-pound bomb blast at 30 yards. Technical Manual TM 9294, 1943, the Americans noticed. Their Quonset hut, developed by the George A. Fuller Company under Navy contract, copied the Nissen's half-round profile but substituted heavier, U.S. standard corrugated steel sheets with wooden end panels. This made them easier to mass-produce, but less resilient under tropical humidity. British officers touring Pacific bases later reported panels warped and sweating under constant heat, while Nissen designs in Burma and North Africa retained structural integrity even under monsoon rains. Bureau of Ships Report, 1943. Yet Britain's real edge lay not in raw materials, but in assembly logic. Each Nissan hut was composed of just 3 standardized components: curved panels, end frames, and bolts. No part required specialized machining, and every joint was symmetrical, allowing soldiers to assemble huts even if plans were lost or reversed. The American Quonset required 16 unique components and exact sequence assembly, a logistical Achilles heel when crates went missing across chaotic supply chains. U.S. Army Quartermaster Technical Note, 1943. The Instant Hut's genius reached its apex during Operation Torch, the Allied landings in North Africa in November 1942. British engineers under Lieutenant Colonel David McMullen landed with the first wave at Algiers. Within 12 hours of securing the beachhead, they had erected an entire field hospital from Nissan components, 60 huts forming wards, surgical rooms, and mess halls. Each panel had been pre-numbered in Portsmouth, allowing the men to rebuild as if following a musical score. War Office Field Engineering Record 1942. By contrast, American units arriving days later at Oran faced chaos. Crates of Quonset components had been scattered across beaches, many mislabeled or damaged. "We had the walls before the roof, and no idea which bolts fit where," recalled one CB officer. "We built in the dark, guessing." U.S. Navy Construction Battalion Diary, Nov. 1942. The result: weeks of delay while British field hospitals treated both nations' wounded under arched steel roofs that withstood desert windstorms like immovable ribs of iron bone. The Nissan's superiority wasn't just physical, it was psychological. Soldiers trusted them. A hut could mean warmth, safety, coffee, mail. It was the difference between endurance and despair. Studies conducted by the British Army Medical Directorate found that units stationed in Nissan accommodation reported 28% lower fatigue rates than those bivouacked in tents. "The curved walls seemed to close the cold out," one infantryman wrote. "When the wind roared, you felt it move, but never break." Army Morale Evaluation Summary, 1943. Behind every panel stood a silent army of workers, women, apprentices, and retirees drafted into Britain's industrial home front. In Birmingham's Castle Bromwich, presses ran night and day under the supervision of factory foreman Elsie Harcourt, who oversaw output exceeding 400 huts per week. Engineers designed mobile rolling machines mounted on lorries, able to press curved panels near docks or airfields, cutting delivery times by 40%. This field manufacturing model, what economists later called distributed wartime production, became the foundation of modern modular construction. Ministry of Aircraft Production Bulletin, 1943. Still, Britain's secret wasn't just efficient production, it was adaptability in the field. In Tunisia's Kasserine Pass, February 1943, British engineers deployed Nissan huts as armored supply depots. By layering 2 huts side by side and filling the space between with sand, they created blast-resistant stores that survived direct strafing runs from Luftwaffe Bf-109s. American observers took notes, astonished that such crude-looking huts could function as fortifications. Field Engineering Observation Report, 1943. The Quonset's defenders argued that America's design was more versatile for mass scale, and they weren't wrong. By mid-1943, U.S. factories produced 20,000 units per month, dwarfing British output. Yet the British advantage remained qualitative. A Nissan hut could endure 5 times as many dismantle and rebuild cycles without structural fatigue. The arched frame, using interchangeable bolt holes, absorbed torque and redistributed stress, an insight derived from bridge engineering, not architecture. British Structural Analysis Board, 1943. A pivotal moment came during the Battle of Sicily, July 1943. Allied engineers raced to construct airfield depots near Palermo under heavy artillery fire. American Quonsets arrived flattened, their pre-assembled arches twisted. The British, using crates of Nissan components, built operational headquarters in 36 hours. Within days, Spitfire reconnaissance squadrons flew missions from huts assembled barely a mile from front lines. German prisoners later described the sight of enemy barracks appearing overnight, as if grown from the ground. Italian Campaign Interrogation Transcript, 1944. But the most striking proof of Britain's architectural genius emerged in the East. In Burma, 1944, Nissan huts became lifelines amid monsoon floods and jungle decay. British and Indian troops stationed near Imphal used bamboo-reinforced variants, combining local materials with imported steel ribs. The hybrid could be built entirely by hand, with mud-packed floors and woven mats replacing steel ends. Even after weeks of torrential rain, they remained standing when wooden barracks rotted to pulp. Southeast Asia Command Construction Record, 1944. the Americans continued improving the Quonset, adding ventilators, insulation, and modular flooring. Yet despite their scale, the simplicity of the original British system proved unmatched in wartime versatility. It wasn't the size of the structure that mattered, it was its philosophy. The Nissen embodied field logic, born from a soldier's eye, easy to carry, quick to build, impossible to misunderstand. Allied Technical Evaluation Committee, 1944. Still, both nations learned from each other. British huts began adopting Quonset-style end caps for insulation, while Americans borrowed British modular numbering for faster assembly. Cooperation transformed competition into synergy. But on the ground, soldiers remembered which shelter rose first, held longest, and demanded least. By late 1944, engineers across Europe were racing to erect forward command posts as Allied armies advanced toward Germany. On the outskirts of Caen, a team of Royal Engineers under Captain Geoffrey Latham built a fully wired signals command hut in 6 hours flat, complete with radio masts and blackout curtains. When a German shell struck nearby, the structure trembled but didn't collapse. Latham's after-action note was terse. Structural integrity, satisfactory. Morale effect, considerable. Royal Engineers Combat Log, July 1944. For the enemy, it was baffling. Captured Wehrmacht notes referred to instant enemy shelters that resist both bomb and flame. One officer wrote, "The British build cities overnight." Wehrmacht Field Journal, 1944 translated. Yet behind that marvel stood something deeper than steel or skill. It was the culmination of Britain's wartime mindset. Innovation through constraint. When every ounce of metal and minute of labor mattered, the nation's engineers turned scarcity into strategy. But even as victory neared, another battle loomed, not on the front lines, but in the reconstruction that followed. The war's most overlooked weapon, the humble hut, was about to redefine the post-war world. When the guns finally fell silent in Europe on May 8, 1945, Britain stood amid the wreckage of triumph. Cities lay in ruins, Coventry, Plymouth, London's East End, all pocked by bomb craters and skeletal chimneys. Millions were homeless, factories gutted, and entire regiments demobilized. Yet, from this devastation, the same structure that had shielded soldiers under fire would now protect families under the cold rain of peace. The Instant Hut had one more campaign to fight, rebuilding Britain itself. Ministry of Works Reconstruction Report, 1945. Within weeks of victory, surplus Nissen huts were being shipped from depots across Europe. In Calais, Antwerp, and Hamburg, British engineers disassembled the shelters that had once housed troops and packed them for transport home. By July, convoys of lorries rolled through the Midlands, carrying hundreds of curved panels stacked like ribs of some metallic leviathan. Civil authorities repurposed them as emergency housing. Temporary, they said, for just 6 months. Yet for many, those 6 months became 6 years. British Housing Directorate Circular, 1946. Entire Nissen villages sprang up around bombed cities. Hut City in Catford, Camp 117 near Nottingham, and dozens more. Inside, families made do among steel arcs that once echoed with military boots. They hung curtains from rafters, painted walls pastel, and christened each hut with a number that became a home. It smelled of oil and hope, one resident later recalled. Post-war civilian testimony, 1948. What had been a weapon of endurance became a vessel of recovery. Britain's engineers adapted designs for peacetime, adding insulation, fitting wooden floors, and installing small stoves. Each alteration carried lessons learned on the battlefield, proof that wartime necessity could birth peacetime resilience. Ministry of Housing Innovation Memo, 1947. Meanwhile, across the Atlantic, America's Quonset huts took on a similar second life. From Okinawa to New Jersey, they became schools, churches, post offices, even diners. At Brown University, returning GIs studied under steel arches. At naval bases, they housed entire families of veterans. The U.S. had produced over 150,000 Quonsets by war's end, each echoing the curved logic first imagined by Nissen in 1916 and perfected by British ingenuity under fire. U.S. Army Corps of Engineers Post-War Utilization Report, 1946. And yet, the quiet rivalry persisted. American historians often credited the Quonset scale, British engineers, its soul. The difference was philosophical. The British version represented craft under constraint, the triumph of simplicity in chaos. The American model embodied industry unleashed, the power of abundance to replicate success. Both were right, but when it came to adaptability, the Nissen's DNA proved timeless. Architectural Heritage Review, 1950. The hut's influence rippled far beyond its corrugated skin. During the Korean War, Modular Quonset derivatives housed UN troops from Seoul to Pusan, while in Britain, civilian architects like Sir Frederick Gibbard studied Nissen proportions to inspire post-war prefabs. Its geometry, efficient, aerodynamic, resistant, became a blueprint for cheap, rapid architecture across the world. The so-called tin hut had become a global archetype of human ingenuity. Royal Institute of British Architects Journal, 1952. Yet beneath the technical triumphs lay a psychological truth. Soldiers who once huddled beneath the curved steel remembered more than shelter. They remembered continuity. A Nissen hut was the one structure that followed them from training fields to battlefronts, from Normandy beaches to occupation zones. It became a symbol of permanence amid impermanence, a promise that wherever they went, a familiar roof awaited. U.S. Strategic Bombing Survey, Troop Morale Section, 1946. The design's endurance was uncanny. Unlike sandbagged bunkers or timber barracks, Nissen huts resisted decay. Many that were built for a 6-month lifespan still stand today, their galvanized ribs dulled but unbroken. They became aircraft hangars, machine shops, scout halls, and storage sheds. Farmers bought them cheap, transforming wartime relics into barns. Even decades later, you can still find their unmistakable silhouettes, arched, defiant, quietly eternal, across the British countryside. Heritage Structures Conservation Record, 1981. But perhaps the most profound impact was invisible. The way these huts shaped post-war military doctrine. The Royal Engineers' success with modular portable infrastructure directly informed NATO's Cold War strategies. By 1950, the concept of rapid deployment engineering units, able to build fully functional bases within 48 hours, was standard. That lineage traces back to the field manuals of 1940 Britain and the Nissen huts that proved flexibility was as vital as firepower. NATO Engineering Doctrine Compendium, 1953. The lesson reverberated through later wars. In Vietnam, the U.S. military revived prefabricated Quonset-inspired systems for jungle bases. In the Gulf War, portable shelters evolved into insulated aluminum modules, their assembly logic identical to that of the Nissen Ark. Even modern humanitarian relief operations, from Rwanda to Ukraine, owe their architecture to that same wartime simplicity. A few men, a few bolts, and a roof before nightfall. United Nations Relief Engineering Handbook, 1992. Yet for all its technical legacy, the Nissen hut remains a deeply human story. It was the product of minds like Peter Nissen, Arthur Payne, and countless unnamed welders, riveters, and machinists who bent steel not for glory, but for survival. Their craft bridged the front and the home front, turning the industrial heart of Britain into a beating artery of endurance. British Industrial War Effort Report, 1945. Post-war memoirs describe a peculiar nostalgia among veterans for the curved huts of their youth. You could hear the rain drum like a snare on the roof, one wrote, and you knew you were alive. Those sounds, the metallic heartbeat of a nation under siege, lingered long after peace returned. Regimental Association Oral History, 1958. In 1948, Major Peter Nissen's widow attended a ceremony at Aldershot, where the last wartime huts were being decommissioned. When asked what her husband would have thought of their survival, she simply said, "He built them to be useful, not eternal. But sometimes usefulness is eternity." Daily Telegraph Archives, 1948. By the mid-20th century, architects began calling such forms austerity modernism. Yet to the men and women who lived through those years, they were something simpler. Proof that genius thrives not in abundance but in limits. The Nissen hut became an emblem of democratic design, where ordinary hands could build extraordinary structures. Architectural Review Quarterly, 1954. Even as glass towers rose and the world forgot the curve of corrugated steel, the philosophy behind it endured. When engineers speak today of modular housing, rapid fabrication, or sustainable assembly, they echo Nissen's wartime creed. Build fast, build light, build to last. And so the story of Britain's instant hut closes not with a monument, but with a silhouette, curved against the horizon, silvered with rust, timeless as memory, because in the end, the Nissen hut wasn't merely architecture. It was strategy made tangible, a symbol of what happens when intellect meets necessity, when design becomes survival. It taught the modern world that war is won not only by those who fire the shells, but by those who build the shelters to outlast them. In modern war, connection outweighs firepower, and speed defeats armor. U.S. Strategic Engineering Assessment, 1946.